Hi everyone, let's start paper 1 multiple choice of AS chemistry, October-November 2023, variance 11. The duration of this paper is 1 hour 15 minutes. We have 40 questions in this paper. We need to attempt all of them, and the total mark for this paper is 40. Let's see what we have in it. Question number 1 seems like belongs to the fundamental particles of an atom. Sodium azide has a formula NaN3, is an explosive used to inflate airbags in cars when they crash. It consists of positive sodium ions. So when we have positive sodium ions, obviously the proton number is 11 and the mass number is 23. My bad. It's right, but the thing is, hold on a second. Yeah. When we have sodium ions, obviously, it has a nucleon number of 23 and the proton number is 11, which means it has 11 protons. Because of plus charge, it has 10 electrons. And so it has 12 neutrons, right? And neutron is neutral, which has 0 charge. And negative is azide. There's a formula of N3 minus. So the atomic number of nitrogen is 7, which means it has 7 protons. Into 3, it becomes 21 protons. All right. Now we have 7 electrons into 3 is going to be 21 electrons. But as it carries negative charge, which means it will gain 1 electron. When it will gain 1 electron, the total number of electrons is going to be 22. So sodium ion has 10 electrons, whereas azide ion has 22 electrons, right? What are the number of electrons in the sodium ion and azide ion? Azide ion has 22 electrons, whereas sodium ion has 10 electrons. So I think B is going to be the right answer. Question number 2. The graph shows the variation in the first ionization energy with proton number for some elements. The letter used are not the actual symbols for the element. All right. This is basically period 2 element. This is basically period 3 element. This is basically transition element. All right. Y-axis has first ionization energy. X-axis is proton number. So which statement about elements is correct? P and Q are the same period in the periodic table. P and Q. This is P, which is found in period 2 of the periodic table. This is Q, which is found in period 3 of the periodic table, which means this is going to be period 2. This must be in period 3, which means they are not found in the same period. So obviously A is incorrect option. The general increase from Q to X is due to the increasing atomic radius. Since it is across the period, so across the period, atomic radius always decreases, not increasing. So this must be incorrect. It should be decreasing. Okay. So this is Q, this is X. So across the period, atomic radius always decreases. So shouldn't be increased. So B is incorrect, obviously. The small decrease from R to S is due to the decreased shielding. Well, this is the period trend. This is also the period trend. All right. So in R and in S, across the period, shielding remains same. The shielding remains same. So C is also incorrect. All right. The small decrease from U to V is due to repulsion between paired electrons. U to V. This element has the highest first ionization energy, which means this element is going to be the noble gas. And according to my lecture, right after noble gas, element belongs to group 1 of the periodic table. So this is group 1, group 2, 3, 14, 15, 16. So U is found in group 15. And so it has 5 valence electrons. 5 valence electrons means S orbital contain 2 electrons and P orbital contain 3. All right. Whereas this V is basically group 16. And so it has 6 valence electrons. All right. If it has 6 valence electrons, obviously those 6 valence electrons can be distributed like this. S contain 2 and P contain 4. So this 3P subshell contain 1 paired electron, and so it will experience spin-spin repulsion, which is also called inter-electron repulsion. So this statement is going to be right. And since this experiences inter-electron repulsion, which means when you provide less amount of energy, electron removal becomes easier, and therefore ionization energy of V is lower than that of U, and therefore D is going to be the right answer. I hope it makes sense to you. Question number 2, and then question number 3. Okay, aluminum carbide reacts readily with aqueous sodium hydroxide. All right. And by the way, aluminum chloride is an ionic compound because it exhibits ionic bonding. It is reacting with aqueous sodium hydroxide. The two products of the reactions are NaAlO2 and a hydrocarbon. Water molecule are also involved as reactant. So we have aluminum carbide as a reactant. We have sodium hydroxide as a reactant. We have water molecule as a reactant. So these are the 3 reactants. So what we can do is we have aluminum carbide, Al4C3. We have sodium hydroxide. We have water. And now it is converted into NaAlO2 and a hydrocarbon. And we really don't need, and we don't know what sort of hydrocarbon is that. So it is represented by CXHY, which we need to decide by using this format. All right. Xavier is asking the formula of the hydrocarbon. And hydrocarbon is basically compounds which contain carbon and hydrogen only, which is why options have only carbon and hydrogen. So I think it's going to be the trial and error method. First, we need to apply this one. If this equation is going to be balanced, then it's fine. Otherwise, we need to apply the same procedure for B, C, and D. So it's a bit technical and tricky because it will take a lot of time. Okay, we have 4 aluminum here. So while use 4, sodium is going to be 4, carbon is going to be 3. Okay, 4. How many hydrogen atoms? How many oxygen atoms here? 4 times 2, 8. So I'll put 4 here to get the total oxygen 4. So how many carbon now? C3. And how many hydrogen atoms now? 8. C3H8. C3H8. So aluminum is 4. Aluminum is 4. Sodium is 4. Sodium is 4. All right. Hydrogen is 4 times 2, 8. 8 plus 4, 12. 12. Hydrogen is 12. No. C3. C3 and H12 is not an option here. So I think it's not going to be the correct one. Let me think. what we can do is, let me put 2 here. So total aluminum is 8. Total sodium is 8. How many oxygen atoms so far here? 8 times 2, 16. Where we have 8 oxygen atom here. So in order to complete 16, we need to put 8 here. Okay. So sodium is 8 balanced. Aluminum is 8 balanced. Oxygen is 2 times 8, 16. 8 plus 8, 16. Hydrogen, how many carbon atoms now? 2 times 3, 6. We have 6 carbon atoms. And we have 8 plus 8, 16 hydrogen atoms. All right. So in order to get the simplest ratio, wait, wait. Am I doing right or wrong? Let me think again. It's tricky. This is 6 ratio, my bad. This is 6 ratio 16. So it's going to be 3 ratio 8. Oh, yes. It's going to be 3 ratio 8. How many carbon after ratio? C3. And how many hydrogen atoms? 8. C3H8 is the hydrocarbon. And therefore, C is going to be the right answer. My goodness, that's not an easy question. A sample of 35.6 gram of hydrated sodium carbonate contained 25.84% sodium ions by mass. Okay. When this sample is heated, anhydrous sodium carbonate and water are formed. Which mass of water was given off? Okay. So in the first step, first find out the percentage by mass of sodium in this sample. We have 2 sodium, so 23 times 2. We have 2 sodium in the sodium carbonate. Sodium carbonate is a formula of Na2CO3. So we have 2 sodium atom in the formula. So the AR of sodium is 23 times 2 because we have 2 atoms divided by the MR of hydrated sodium carbonate. So hydrated sodium carbonate is Na2CO3 dot XH2O because we don't know the value of water. We don't know the value of X. So what we can do is divide by MR. MR is 106 plus X times 18. All right. And the percentage in this sample is basically 25.84. My second step is 28.84 equals to 23 times 2 divided by 106 plus 18x. All right. So this must be the step now. 106 plus 18x equals to equals to oh into per 100 भी तो है. Okay. My bad. Wait. I'm running out of space. This one is first part. Second part, second is 25.84 equals to 23 times 2 divided by 106 plus 18x. into 100. So what we can do is in the next step, we can find the value of x. So 106 plus 18x equals to 23 times 2 times 100 and divided by 25.84. Oh, so from here, the value of x is going to be 4. All right. So value of x is going to be 4. Now, sodium carbonate dot 4H2O would be the hydrated crystal. When you heat it, it will turn to sodium carbonate and 4 moles of water. The MR of this compound, MR of this hydrated compound is going to be 178. Okay. So let me get the moles of sodium carbonate. 35.6 divided by the MR, which is 178. So it's going to be how much? 35.6 divided by 178 is going to be 0.2 mole, right? Now sodium carbonate and water has 1:4 per ratio. So moles of water is going to be 0.2 into 4 is going to be 0.8 mole. We need to find out the mass of water. So in order to find the mass of water, 0.8 into 18 is going to be into 4 into 18 is going to be 14.4% or 14.4 gram. Is there anything written like this in the option? 14.4, not possible, not possible. 14.4, the C is going to be the right answer. I hope it makes sense to you. That's a very, very tricky question. First, you need to find out the value of X in this percentage by mass of sodium. And from that value of X, you can determine the MR. By using this mass and the MR, you can find the moles. By using the equation, you can find the moles of water through molar ratio, and you will get the mass of it. All right? My goodness. Question number 5. Solid aluminum chloride sublimes at 178 degrees Celsius. 178 degrees Celsius. All right. Which structure best represents the species in the vapor at this temperature? By the way, aluminum chloride is AlCl3. When it sublimes at this temperature, it's going to be converted into Al2Cl6, which is also called dimer. Remember one thing, this dimer exhibit dative bonding. So obviously option D is incorrect because in dative bonding, it is a covalent molecule, so it has no charge like this. In fact, Al2Cl6, whereas this option is just AlCl3, which is not possible in the vapor form, in the sublime state, which is why D option is incorrect. C is also incorrect because after the formation of dimer, it has to be Al2Cl6. Now, competition exists between this and this. So, dative bond, aluminum has no lone pair, so it cannot form dative bond. So, these arrow are wrongs. Right answer is going to be an A because Al2Cl6 has the structure like this. We have discussed it in class, right? Which row is correct? Shape of H3O plus. Well, let me write the structure of H3O. Oxygen belongs to group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. as we have a positive charge on it, which means it lost one electron. So when it lost one electron, so around oxygen we have 3 bond pair. Around oxygen we have 1 lone pair. So in total we have 4. Draw the structure of 4 lines. The first one is s orbital. The remaining line is the p orbital. So the hybridization is sp3. So whenever you have 3 single bond and a 1 lone pair with sp3 hybridization, angle is going to be 107 degree and the geometry is going to be trigonal pyramidal. Okay. So this is pyramidal, this is pyramidal. Obviously, C and D are incorrect options. Let's talk about the shape of SCl2. Again, let me write the structure of SCl2 like this. Distribute the valence electron of sulfur. As sulfur has 6 valence electrons because it is found in the group 16 of the periodic table. So we have a situation like this in which we have 2 bond pair and a 2 lone pair. Again, total is going to be 4. Let's draw the 4 line. Hybridization is going to be sp3. So if you have sp3 hybridization with 2 single bond and 2 lone pair, the angle is going to be 104.5 degree, non-linear shape, band shape, angular shape, or V-shaped geometry, or crooked shape geometry. All right. So non-linear. So right answer is going to be A. When an evacuated tube of volume 400 cm cube, obviously if it is cm cube, it has to be in meter cube. So 400 into 10 to the power minus 6 meter cube. Okay. 300 Kelvin. Pressure is 101 kilopascal. So converted into Pascal. So it's going to be 1 kilopascal equals to 1000 Pascal. So if we have 101 kilopascal, it's basically 101,000 kilopascal or 101,000 Pascal, correct? And the mass is increased by 0.65. So we know the pressure, we know the volume, we know the temperature, we know the R value, the identity of gas, and for the identity of gas, we should know the MR or AR of the gas. Okay. So let me apply PV equals to nRT directly. PV equals to nRT. N is basically mass upon MR, like this. Okay. We know the pressure, which is 101,000 Pascal. Volume is 400 into 10 to the power minus 6 equals to mass. Mass is 0.65. R value is 8.31. Temperature is going to be 300 Kelvin. Divided by MR, we need to find out. So MR is going to be how much? Let me calculate MR. So MR is going to be, hold on, 0.65 into 8.31 into 300. So it's basically 1620.45 divided by 101,000 into 400 exponent minus 6 is going to be 40.4. So 1620 divided by answer is going to be 40.4. And 40.4 is basically the argon, because in periodic table, the AR of argon is 39.9, which is close to 40. Helium cannot be an answer because its AR is 4. Krypton is, I think, 85, which is too higher. Neon is way too lower because its AR is 20, which is also wrong. So I believe A is going to be the right answer. Okay. Question number 8. Nitrogen and carbon monoxide both have MR28. The boiling point of N2 is 77 Kelvin. By the way, nitrogen is also non-polar. It has instantaneous dipole induced dipole forces, which is also called van der Waals forces. The boiling point of CO is 82 Kelvin, which is relatively higher than this one. And why CO is basically a polar covalent molecule because of more electronegative oxygen. And also it has a linear geometry. And so it has permanent dipole forces. All right. What could be responsible for this difference in the boiling point? Carbon monoxide molecule has a permanent dipole. That's right. The nitrogen molecule are not polar. That's also right. So A is going to be the right answer, but let me read other options. Nitrogen has sigma and pi bonding. Carbon monoxide has pi bonding only. No, carbon monoxide exhibit my bad, exhibit pi bond also because it contained triple bond. So this option is incorrect. Nitrogen has a strong triple bond, whereas carbon monoxide has a. That's again wrong statement because carbon monoxide has also a triple bond. We have discussed it in class. Okay. The carbon monoxide has more electron than nitrogen molecule. By the way, both nitrogen and carbon monoxide are isoelectronic. Isoelectronic means they have same number of electrons. And obviously, this is going to be incorrect again. Question number 9. Which statement about enthalpy change is correct? Enthalpy change of reaction are always negative. Not really, because for some reaction, it could be positive. Because it varies from compound to compound. Okay. Next, so option A is incorrect. B, enthalpy change of combustion are always positive. Combustion is always negative. Delta Hc is always negative. Okay, so option B is incorrect. Enthalpy change of formation are always positive. Not always. Enthalpy change of formation, I told you in the class, could be positive, could be negative. So obviously C is also incorrect. If A, B, C are wrong, obviously D is going to be the correct one because neutralization is always negative. Okay, question number 10. What is the definition of standard enthalpy change of neutralization? Standard enthalpy change of neutralization, the definition. Definition is quite easy. Definition is, my bad, when 1 mole of water is formed when an aqueous acid and aqueous alkali react together. So on the basis of that, when 1 mole of aqueous acid is neutralized by aqueous alkali, no. 1 mole of water should be formed. So option A is incorrect because neutralization is all about the formation of 1 mole of water. Instead, 1 mole of acid and 1 mole of alkali are reacting together. Similarly, when 1 mole of aqueous alkali is neutralized, again wrong because examiner is specifically talking about 1 mole of water, is looking for that particular statement instead of 1 mole of acid and alkali. When 1 mole of an aqueous acid is neutralized by 1 mole of aqueous alkali, again it is wrong. So option D is correct. When an aqueous acid and an aqueous alkali react together to produce 1 mole of water. So that's the definition. The right answer is D. Okay. Question number 11. HOCl, chloric 1 acid, is the molecule that kills bacteria when chlorine is added to water. The following reaction produces this molecule. Now, in this equation, Cl2 is converting into chloride ion, as you can see in the equation. So chlorine molecule has an oxidation state of 0 and chloride ion has a charge of -1. So it's basically the decrease in oxidation state, and therefore it is basically the reduction process. Okay. So in this reaction, chlorine is getting reduced. All right. In the same reaction, chlorine is converting into HOCl. In HOCl, the oxidation state of chlorine could be +1. Let's find out. Let's suppose chlorine is X. Hydrogen has a charge of +1. Oxygen has a charge of -2, equals to 0 because molecule is neutral. And therefore, X equals to +1. So basically, oxidation state of chlorine changes from 0 to +1. And therefore, it's going to be oxidation. So chlorine is simultaneously reduced and oxidized in the same reaction. So when a single species is simultaneously oxidized and reduced in the same reaction, this reaction is called disproportionation reaction. Okay, so on the basis of that, A is going to be the right answer. Question 12. Nitrogen dioxide, NO2, exists in equilibrium with dinitrogen tetroxide. By the way, we have 2 moles here. And we have 1 mole here. It is also exist in gas. It is also exist in gas. And then enthalpy change is negative, which means forward reaction is exothermic. So what sort of conditions we need to provide to get the greatest percentage of N2O2 at N2O4 at equilibrium? So need to get the greatest percentage. Okay. In order to get the greatest percentage of N2O4, the equilibrium must move towards right-hand side. And for that, I will use high pressure, because according to Le-Chatelier's principle, if we increase the pressure, equilibrium favors in that direction where we have less number of moles. This product has less number of moles, which means equilibrium favors towards right-hand side, and therefore you will get the high yield. So high pressure could be the one possible scenario in order to get the greatest percentage of N2O4. So option C and D is incorrect. Let me write that statement because it's very, very important. Increasing pressure favors equilibrium towards right-hand side because of less number of moles. Thus, percentage of N2O4 increases. Okay, this is my first statement. Okay, since the reaction is exothermic and we want to increase the percentage of N2O4, so for any exothermic reaction, we need to reduce the temperature so that equilibrium favors towards right-hand side. So reducing the temperature is basically favors the equilibrium towards right-hand side, and therefore my answer is going to be D. Okay, so let me write this statement also. Decreasing the temperature in exothermic reaction favors equilibrium towards right-hand side, hence percentage of N2O4 increases. All right, guys, question number 13. When an equimolar mixture of H2 and I2 react, and If examiner is saying equimolar, which means they are reacting in 1:1 ratio. Okay. The mole fraction of HI in the final mixture is X. So mole fraction, what was the mole fraction? Mole fraction was moles of gas over total moles. Is mole fraction, okay? So the mole fraction of HI is already given. What is the equilibrium constant Kp for this reaction? To find the Kp, we need to find out the partial pressure of all the gas. All right. So the equation could be like this: H2 plus I2, reversible sign, 2HI. So the mole fraction of HI at equilibrium is X. And we don't know the mole fraction of H2 and I2, so which we need to find out. By the way, remember one thing. That the sum of mole fraction is always equals to 1. All right. So let's suppose it is Z. It is also Z. So Z plus Z plus X equals to 1. Then 2Z plus X equals to 1. Then Z equals to 1 minus X upon 2. So mole fraction at equilibrium is going to be 1 minus X upon 2, 1 minus X upon 2. Both hydrogen and iodine have same mole fraction because 1:1 ratio. And the mole fraction at equilibrium of HI is X. Now find out the partial pressure of hydrogen. To get the partial pressure, moles of the gas, which is 1 minus X upon Z. I mean, moles of the gas over total moles, so it's going to be the mole fraction. So the mole fraction of H2 is 1 minus X upon 2 into total pressure, which is not given obviously in the question. So we don't need to use it either, right? It's all right if you can't use this, but let's stick to the protocol, what we have discussed in the class. Then partial pressure of I2, so it's going to be the mole fraction, which is 1 minus X upon 2 into total pressure. And the partial pressure of HI is basically mole fraction, which is X, into total pressure, which is PT. So these are the partial pressure of all the components. We need to place them in the formula of Kp. So Kp is equals to partial pressure of HI, and since HI has 2 moles in the equation, so it has to be in the power over partial pressure of hydrogen into partial pressure of iodine. All right, let me plug in the values in this. Partial pressure of HI is X times PT power square over 1 upon X, 1 minus X upon 2 into into PT times 1 minus X upon 2 into PT. All right. So PT is cancelling out with each other. So it's going to be x square upon 1 minus x upon 2 square. So it's going to be x square upon 1 minus x whole square over 4. All right. So in let me wait. Let me get the space for myself. I'm running out of space. All right. So it's going to be x square over 1 minus x whole square over 4. So for Kp, it's going to be 4x square over 1 minus x whole square. So this is going to be the answer. I believe C is going to be the answer. Okay. I hope it makes sense to you. All right. Let's start question number 14, guys. In reaction 1, the student measures the initial rate of production of carbon dioxide and copper carbonate is reacted to 50 cm cube of 0.1 mole per dm cube nitric acid. So we have copper carbonate and it is reacting with nitric acid. Obviously, copper nitrate, carbon dioxide and water is formed. And that's how you can find the initial rate of production of carbon dioxide, okay, by collecting the volume of carbon dioxide. In reaction 2, the student repeats the same experiment using 50 cm cube of 0.5 mole per dm cube nitric acid and the same mass of copper carbonate is used. If same mass of copper carbonate is used, then it means same amount of carbon dioxide has been produced, right? In reaction 1 and reaction 2, the acid is in excess. That means copper carbonate has to be the limiting reactant. Okay. And sample of the same copper carbonate are used. Which row is correct? The examiner is looking for the rate of reaction. And rate of reaction depends on concentration. Over here, lower concentration we have. If we have a lower concentration, obviously effective collision in unit time decreases. So rate of reaction decreases. Whereas in the second experiment, the concentration increases from 0.1 mole per dm to 0.5 mole per dm. So if the concentration is higher, effective collision in a unit time increases. And so rate of reaction increases. So first of all, let's talk about the rate of reaction both in experiment 1 and experiment 2. So in experiment 1, we have low rate of reaction. Okay. So this must be lower or slower. In experiment 2, rate of reaction is faster. And obviously, if one value is lower and the other value is higher, so lower over higher becomes less than 1, right? Not more than 1. So this is incorrect option. It is also incorrect. This one is right. This one is right. Obviously, A and B are incorrect options. So lower value of in experiment 1, higher value in experiment 2, the lower value over higher value will give you the lower value, which is going to be the less than 1, right? So C or D could be the right option. Let's talk about the effective collision in unit time. So in effective collision, I've told you that effective collision in experiment 1 decreases, whereas effective collision in a unit time increases in experiment 2. So again, it has lower number of collisions and it has greater number of collisions. So lower over greater will give you smaller value, which must be less than 1. So obviously D is going to be the right answer. Okay. Question 15. The forward reaction of a reversible reaction is exothermic. Forward reaction is exothermic, which means delta H is negative. Has an activation energy of plus 330 kilojoule per mole. Which statement about the activation energy of the reverse reaction is correct? Reverse reaction. Okay. Let me make the energy profile diagram. Oops. On y-axis, we have energy. On x-axis, we have reaction coordinates or progress of reaction. Since forward reaction is exothermic, which means energy of reactant is lower than that, energy of product is lower than that of reactant. So this must be your reactant and this must be your product. So in an exothermic reaction, the energy of product is lower than that of reactant. Okay. So this is going to be the activation energy for this reaction. And this activation energy is basically what? Wait. This activation energy is basically plus 30 kilojoules per mole. Okay. This is for the forward reaction activation energy. Now let's talk about option A. The activation energy for the reverse reaction is equal to minus 130, is equal to reverse reaction is going to be like this. And obviously this activation energy is the sum of plus 30 and delta H. That means it is not equal. It is not equal. It must be greater than 30. All right. It must be greater than this value because we have delta H now. We have delta H. So this is the delta H for the forward reaction. All right. So if I'm going backward or if I'm considering the reverse reaction, obviously it's going in this direction. Obviously, when it will go in this direction. Obviously, you need to add these two values to get the activation energy for the reverse reaction. Okay. So it must be, it couldn't be an equal value. Next, the activation energy for the reverse reaction is greater than 0, but less than 30. It has to be greater than 30 because it is a sum of both these and this value. It is a sum of delta H and this. So couldn't be this, couldn't be this. The activation energy for the reverse reaction is equal to, cannot be equal to, because it is a sum of activation energy and enthalpy change. The right answer is going to be D. Let me check what D is talking about. Activation energy for the reverse reaction is greater than plus 30. That's right. It is. This value must be greater than 30 because it is a sum of delta H and activation energy. So I think D is going to be the right answer. Question number 16. Okay. X, Y, and Z are elements all found within group 13, 14, and 15 of the periodic table. Okay. We really don't know whether all of them are belong in group 13 or group 14 or group 15 or XY in 14 or XY in 15 or XY in 13. So we don't have any clue about that. Anyhow, let's move on to the next part of the question. X is in the same group of the periodic table as Y. Okay, so both X and Y are in the same group. This is the first proof. X and Y are in the same group. Whereas Y and Z are in period 3. If Y and Z are in period 3, so obviously germanium and arsenic won't be the right option because they are not found in period 3 elements, right? The next clue is Y and Z are in same period. Okay. Now the next clue is the first ionization energy of X is greater than first ionization energy of Y. And that's very, very important. X has a higher ionization energy, higher first ionization energy than this. So this must be lower first ionization energy. Okay. So boron has higher first ionization energy than aluminum. This statement is applicable here. Nitrogen has more ionization energy than phosphorus. This statement is applicable as well here. So option B and C are absolutely incorrect because we are looking for the period 3 or either period 2 because okay, next is the melting point of Z is less than melting point of Y. Melting point of Z is less than melting point of Y. Melting point of Z is less than melting point of Y. Okay. Okay. This is our third clue. Z has higher melting point than Y. Now the next is Y and Z both forms chloride. Okay, Y and Z both forms chloride, which are white solids. That's a very, very powerful information. So Y is here. Y has aluminum, silicon, and phosphorus, and we need to form chlorides. So Y forms AlCl3, SiCl4, and then PCl3. All right. By the way, it is liquid at RTP. It is also liquid at RTP. We have given this information in periodicity. So obviously silicon and phosphorus won't be the right option because they are solids. All right. Whereas aluminum chloride is solid. So this must be correct. I think boron has a higher first ionization energy than aluminum. Uh, that's the statement, right? Both B and aluminum are found in the same group. Both are found, it is found, Y and Z are in period 3. Okay. I believe nitrogen has higher first ionization energy than phosphorus. Oh, this is also incorrect because PCl3 forms covalent chloride. So I believe D is also incorrect. A is going to be the right answer. I hope it makes sense to you. That's a trial and error method. Examiner has given me this information. All right. On the basis of this information, so why has aluminum, silicon, and phosphorus? As I've told you that aluminum forms aluminum chloride, which is solid at RTP, whereas silicon tetrachloride and PCl3 both are liquid at room temperature and pressure. Since examiner is talking about white solid, which means I'm going to cross these options, and therefore B, C, and D are incorrect, and therefore A is going to be the right answer. Okay, that's a tricky part. Question 17. Which row about silicon and magnesium and their ions are correct? And their ions. Okay. Comparison of silicon and magnesium. This is magnesium, aluminum, and silicon, and this is sodium. This is period 3 element. So when we move from left to right in a period, shielding remains same. Atomic radius decreases. Nuclear charge increases. Okay. Also, this is the first statement. Okay. Also, we need to compare silicon and magnesium. So magnesium has 2 plus charge, whereas silicon has 4 plus charge. So obviously, when you move from here to here, nuclear charge increases. Proton to electron attraction increases. Size of the cation or cationic radius decreases. And one more thing, both magnesium ion and SiF4 both are isoelectronic ions because they have same number of electrons. I can show you those same number of electrons. Let me give you certain help here. See, magnesium has 12 protons and 10 electrons, whereas silicon has 14 protons and 10 electrons, which means in silicon we have more protons and electrons. And so it has a stronger proton to electron attraction, which is why it has a smaller ionic radius or a smaller size of cation. Okay. Third statement is magnesium and silicon. It has metallic bonding. It has giant covalent structure. Good electrical conductivity because of the presence of C of electron or C of delocalized electron. It is semiconductor because it is semiconductor. Okay, so these these are the points which I've given you in the lecture, which I have summarized here for the question. Let's talk about option A. Silicon has a greater atomic radius than magnesium. No, its atomic radius decreases, which means silicon has a smaller radius than magnesium. And so this statement is incorrect. Obviously, option A is also incorrect. Silicon has a lower conductivity than magnesium. All right, silicon is semiconductor, and whereas magnesium has good conductor. So this statement is right. Let's talk about option here. Silicon has 4 delocalized electrons per atom. Silicon is non-metal. It has not it has no metallic bond, and so it has no delocalized electron, which means this statement is incorrect, and therefore B option is also incorrect. Silicon has a lower melting point than magnesium. Silicon has a giant covalent structure, so its melting point is higher. Examiner is saying lower, which is why this statement is incorrect, and therefore option C is also incorrect, and therefore D is going to be the right answer. Let me check whether it's right or wrong. The radius of silicon ion is smaller than the radius of magnesium ion. This is the statement which I've given to you. That's right. Let me check. Silicon has a greater nuclear charge than magnesium. Yes, silicon has a greater nuclear charge than magnesium. All right. So this statement is also right, and therefore D is going to be the right answer. Question number 18. Bromocresol green is an acid-base indicator. Low pH, it is 3.8. Below pH of it is yellow. Okay. So at 3.8 it is yellow. Above pH 5.4 it is blue. Okay, we have two values, 3.8, which shows yellow, and then 5.4, which is blue. And between these values, it is green. Oh, so between these two values, it is green. Okay. So green must be the neutral solution. Okay. And this is acidic pH. And this is also acidic pH. Okay. No, these are the pH of indicators actually. So let me remove this. Okay. Let me read the question first. Bromocresol green is added to aqueous solution form when chloride of element T is added to water. Now we have two different elements in T, silicon and magnesium. So when silicon reacts with chlorine, it is converting into silicon tetrachloride. When this silicon tetrachloride is placed in water, it's going to be converted into SiO2 plus 4HCl. Okay. Whereas magnesium when placed, or when magnesium is treated with chlorine, it will turn to magnesium chloride. And when magnesium chloride is placed in water, you will get an acidic solution of pH 6.5. Whereas over here, the pH is approximately 2 to 3, right? So the color becomes yellow. Obviously, the pH, acidic pH is 2. To 3. Obviously, at this pH, the solution becomes yellow. That indicates it has to be silicon instead of magnesium, because magnesium has a pH of 6.5, and obviously at this pH, it's going to be blue. An examiner is saying it is yellow. If it is yellow, then it means it has to be a strong acidic solution, and that strong acidic solution is obtained through SiCl4, which means silicon could be the right option here in element T. Obviously, magnesium is going to be incorrect because it will give you a solution, acidic solution with pH 6.5, which is not possible, because at this pH, I'll get the blue color, not the yellow one. Whew, technical area. Okay, now the next part of the question is, when an excess of solid oxide of element U is slowly added to this yellow solution. So this yellow solution is HCl basically, okay? Because it is an acidic solution. And the oxide of U. Now U has how many elements? Sodium and phosphorus. Sodium forms sodium oxide. And obviously when it is treated with HCl, is going to give sodium chloride and water. So I need to balance the equation like this, okay? So this must be the basic oxide. Since it is a basic oxide, can react with acidic solution. So sodium could be the right option, and therefore A is going to be the right answer. Because if it is a basic oxide, obviously you will get an alkaline solution when you add it in water. Okay, which is why the solution turns blue. Why not phosphorus? Because HCl is an acidic solution. HCl has an acidic solution, and the oxide of phosphorus is P4O10. It is also acidic oxide, and two acidic species cannot react together. So reaction cannot take place. I hope it makes sense to you now. Question number 19. Which row correctly describes the separate reactions of calcium and strontium with water? Okay. So when calcium reacts with cold water, it is converting into calcium hydroxide and hydrogen gas. So we have +1 charge here, +0. So decrease in oxidation state. That means HCl is reduced, hydrogen ions are reduced, whereas calcium is converting into calcium ion. So it is getting oxidized. The substance reduced is basically water, because the oxidation state of hydrogen in water is going to be +1 to 0. Substance oxidized, calcium or strontium, because changes in oxidation state from 0 to 2 plus. More vigorous reaction, more vigorous reaction. Down the graph, reactivity increases, which means strontium is more reactive than calcium. So if strontium is more reactive than calcium, then it means strontium reacts more vigorously with water. So I believe this is incorrect, and so A and C are incorrect. All right. Therefore, right answer is going to be D. Okay. So calcium changes its oxidation state from 0 to +2, and therefore it is oxidized. And same criteria goes for strontium, which means the substance oxidized in this reaction is calcium or strontium. Question number 20. L and M are both compounds of group 2 elements. N and N are both soluble in water. When solution of L and M are mixed, a white precipitate is formed. We need to find the white precipitates. We need to make the white precipitates by using L and M. So when I use barium chloride and magnesium sulfate, obviously I'll get barium sulfate and magnesium chloride. Barium sulfate is insoluble. Examiner is saying soluble, which means this statement is incorrect. So when barium nitrate and magnesium chloride are involved in the reaction, obviously, let me write the direct products. Obviously, you are getting barium chloride and magnesium nitrate. Guys, all nitrates are soluble. All barium chlorides are soluble. So this is also soluble. This is also soluble. So we are not getting any precipitates in this scenario. It's also correct. Barium carbonate is insoluble in water. Examiner has given a clear instruction that it is soluble, which means it is also incorrect, and therefore A is going to be the right answer because barium sulfate has white precipitates. As white precipitates. Okay. It is also soluble, and it is also soluble in water. Question 21. A 5-gram sample of an anhydrous group 2 metal nitrate loses 3.29 gram in mass when heated strongly. Which metal is present? So either I will go for the trial and error, in which I will use each and every metal one by one, or either I will go for the overall method in this regard. So this is basically metal nitrate. It is converting into metal oxide, nitrogen dioxide, and oxygen. Sample has a mass of 5 gram, and the loss in mass is 3.29 gram. So remaining mass must be 5 minus 3.29. You will get how much? 3.29, you will get 1.71 gram. Okay. All right. So we know the mass. So, and we know the mass of sample, and we know the mass of this substance. All right. So we can equate these two values. So mass of sample is 5.0 divided by MR of this nitrate. So M will remain as it is because I don't know. I have to find out that. Plus NO3 is 14 plus 16 times 3 is going to be 62 times 2. This is whole 63, and times 2 is going to be 124 equals to mass of MO is 1.71. We need to find out the M, so it will remain as it is, and oxygen is 16. All right. So what we can do is we need to cross multiply these two values so that we can find this one. So after cross multiplication, I'll get the whole, I'll get this value. 5 into M plus 16 equals to 1.71, then M plus 124. Okay. So M, so 5M plus 80 equals to 1.71 m plus equals to plus 212, right? So 1.71 m, the 1.71 into 124 is going to be this one. Let me arrange m value. So it's going to be, take m as a common, then 5 minus 1.71 equals to 212 minus 80, then 212 minus 80, 212 minus 80, 212 minus 80 is going to be 132. So it's going to be m 5 minus 1.71 equals to 80, sorry, 132, sorry, 132. Then m equals to 5 minus 1.71, 80 divided by this. Okay. So let me check my calculation. Did I make any sort of mistake? 212 minus 80. Okay, 5 minus 1.17, 5.71. Okay, 3.29. 132 divided by this. Yes, that's the answer. So 132 divided by 5 minus 1.71 is going to be 3.29. So m is going to be 40 point 132 divided by 3.29 is going to be, my goodness, 132 divided by 3.29 is going to be 40.12. Okay, so 40.12 reflects calcium. Okay, so B is going to be the right answer. I hope it makes sense to you. That's the simple mathematical calculation. I compare this and this, these two substances to get the value of M. Okay. Okay, next question number 22. Q represents an atom of chlorine, bromine, or iodine. Which explanation for the variation in the volatility down group 17 is correct? I've told you in the class, the volatility down the group volatility decreases due to the increase in the boiling point and the increase in van der Waals forces. Okay. Exhibits instantaneous dipole, induced dipole's forces, higher boiling point. Okay. Let me read. Instantaneous dipole, induced dipole forces between molecules becomes stronger. That's right. That's the answer. Let me read other options. Permanent dipole forces between molecules, not possible. Not possible. These forces are not possible because molecule is because all halogens are non-polar. And so they exhibit instantaneous dipole induced dipole forces. Okay. Next, the bond energy of Q2 molecule decreases. Bond energy has nothing to do with the volatility, all right? Has nothing to do with volatility. So bond energy has nothing to do with the volatility. Similarly, ionization energy has nothing to do with the volatility. So option D is incorrect. 23. Which statement about the halogens or halides is correct? Halogens are oxidizing agent, halides are reducing agent. You must know this. You must remember these two informations which I have given you in the class, right? So bromide ions reacts to form a white precipitates. Oh, that's the mistake. Bromide cannot give white precipitates. Bromide always gives creamy precipitates when you treat it with silver nitrate solution, which is why option A is incorrect. Bromine does not oxidize chloride ions when added to sodium chloride solution. Obviously, bromine is less reactive than chlorine, which is why bromine cannot oxidize chloride ions, and that's why B is the right answer. Okay. Next option, fluorine atoms forms cations by accepting electrons when they react. When they are accepting electrons, obviously they cannot form cations, they always forms anions. That's a very simple sort of reasoning. Chloride ions are a stronger reducing agent than iodide ions. Wrong. Chloride ions, weaker reducing agent than iodide ions, okay? Because iodide is stronger reducing agent and chloride is a weaker reducing agent. Down the group, reducing power of halide ions increases, which I've told you in the class. All right. Question number 24. In ammonium cyanate, heated in the absence of air, the only product of the reaction is urea. This is the formula of urea. No other products are formed in the reaction. What is the formula of the cyanate ion present in ammonium cyanate? Okay, that's trial and error. First of all, let's apply NH4 plus 1 and CON2 minus 1. So if you cross multiply these values, you will get one ammonium ion and one CON2 ion. So how many nitrogen we have? 2. How many hydrogens we have? 4. One carbon and one oxygen, right? Oh, my bad, my bad. This is total 3 nitrogen atom, okay? You have to be careful, guys. We have 2 nitrogen here. We have 1 nitrogen here. So if you add these two values, I'll get 3 nitrogen. Whereas in urea, we have only 2 hydrogens. Oh, sorry, 2 nitrogen. In urea, we have 2 nitrogen, 4 hydrogen, 1 carbon and 1 oxygen. This is urea. So that's not possible. Okay. Because nitrogen are not balanced. Let's talk about B. We have ammonium ions, which has a charge of +1. We have another ion, which has a charge of 2 minus. If you cross multiply this, obviously it's going to be twice. If it's going to be twice, let me write it one more time. So how many nitrogens we have in this whole scenario? We have 4 nitrogen atoms. 1, 2, 3, and this one is 4. So we have 4 nitrogen atoms. How many hydrogen atoms? 8, 1 carbon, and 1 oxygen. Obviously, this formula is not, reflecting the formula of urea. Again, this is incorrect, and obviously B is also incorrect. Let's talk about C. Ammonium ion has a charge of +1. OCN minus has a charge of -1. If you cross multiply this, you will get what? How many nitrogen atoms? 2. How many hydrogen atoms? 4. 1 carbon, 1 oxygen. Now this formula and this formula is exactly the same one, which means C is going to be the right answer. Okay, I hope it makes sense to you. Question 25. Hexamine is a crystalline solid used in fuel is portable stoves. The diagram shows its skeletal structure. What is the empirical formula of hexamine? First of all, let's count the carbon atom. 1, 2, 3, 4, 5, and 6 carbon. So guys, we have 6 carbon in this. Hydrogen. 2, 4, 6, 8, 10, and 12. Okay. We have 12 hydrogen atoms. How many nitrogen? 1, 2, 3, 4. We have 4 nitrogen atoms. So we have 6, 12, 4. So let me divide this by 2. It's going to be 3, 6, and 2. So the empirical formula is C3H6N2. So I believe B is going to be the right answer. The compound aspartame or aspartame is widely used as a sweetener in diet soft drinks. Aspartame is chiral, and benzene has no chiral carbon atom. Okay, so this one has no chiral carbon atom. How many chiral carbon atoms are present in a molecule of aspartame or aspartame? This is not going to be the chiral carbon because 3 hydrogen atoms are attached. This is not chiral because 2 similar hydrogens are attached. This is double bonded carbon atom, no chiral. Double bonded carbon atom, no chiral. Double bonded carbon atom, no chiral. So only two carbon. This is CH2, which is not chiral as well. So how many left? This one and that one. So these 2 chiral carbon atoms exist in this. How come? Let me give you an example. This is first group. This is second group. This one is third. And this entire thing is the fourth group. Okay. Similarly, this one is first. This one is second. This one is third. And this entire thing is fourth group. So we have only 2 chiral carbon atom in this compound. So answer is going to be B. Question number 27. How many sigma and pi bonds are in the molecule of this? So let me open the structure. Let me make the displayed structure of this molecule. How many carbon atoms we have? 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let me write the carbon atom. 1, 2, 3, 4, 5. This one is 6. This is CH3, guys. Or let me write the displayed structure. This is CH3. Whew. And this is CH3. Okay. This is H. So I'm done with this. I'm done with this. This carbon has 2 hydrogen atoms. Over here, we need to make 2 hydrogen atoms. Okay. Next is 2 hydrogen atoms. Then CH. And obviously, it has to be a double bond here. And it has to be a double bond here to satisfy the number of bonds of carbon. And it has to be a triple bond here to satisfy the number of bonds of carbon. I hope it makes sense to you. Okay. Sigma and pi bond. So when you have triple bond, you have 1 sigma and 2 pi. When you have double bond, you have 1 sigma and 1 pi. So in total, we have 3 pi bonds. So 3 pi bond is here. 3 pi bonds is here. Obviously, this option and this option is absolutely incorrect. So competition exists between A and D. Let me check. Sigma bond. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 sigma bonds. The 19 sigma bonds, and therefore D is going to be the right answer. Okay. Okay, now the next is the hydrocarbon C17H36 can be cracked. In cracking, I've told you in the class, short chain and more useful hydrocarbons are formed. Now the question is, which compound is least likely to produce in this reaction? Least likely to produce in this reaction. This is a short chain this is a short chain hydrocarbon. It will produce obviously, so it's going to be incorrect because least likely ki baat kar rahe hai. C4H8 is a short chain and more useful. C8 as compared to C17H36 is a short chain, but D is going to be the right answer because from C17H36 I cannot get C16H34 because it is not a short chain, it is a long chain hydrocarbon. So long chain hydrocarbons are least likely to be produced in this reaction. Long chain hydrocarbon. Okay. So let's talk about 29, question number 29. Which compound has an MR of 84 and will react with HBr to give a product with an MR of 164.9? So compound must be an alkene because it is reacting with HBr. So obviously A option is incorrect because it is not an alkene. C is ketone, not an alkene. So combination exists between B and D. So the MR of compound is 84. Let me get the MR of this compound. 1, 2, 3, 4, 5, 6, 7 carbon. I repeat, 1, 2, 3, 4, 5, 6, 7 carbon. So we have 7 carbon. So 17 times, my goodness, 7 times 12 plus hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 plus 14. So MR is going to be how much? 12 times 7 plus 14 is going to be 98. So this must be incorrect option. The right answer is going to be D. Let me get the MR of D. 1, 2, 3, 4, 5, 6 carbon atom. So 12 times 6 plus, let's count hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 hydrogen atoms. So 12 times 6 plus 12 hydrogen is going to be 84. All right. And also, when you add HBr, take out the MR of HBr. HBr. Hydrogen is 1, bromine is 79.9. So if you add these two values, it's going to be 79.9 plus 1 is going to be 80.9. So when you add 84 in it, plus 84 plus 84, you will get 164.9. 164.9. So that was the MR of the product. Okay, that means It is an alkene, and it is reacting with an HBr. I hope it makes sense to you. That's an easy question, by the way. Question 30, I have solved this question in my topical past papers. In topical past papers video recordings, right? You can see them. I've already shared with you. So beta carotene is responsible for the orange color of carrots. Beta carotene is oxidized by hot concentrated esterified K1O4. When hot concentrated esterified K1O4 is used, either I'll get carboxylic acid or either I'll get ketone. Okay. All right. When an individual molecule of beta carotene is oxidized in this way, many product molecules are formed. How many? How many of these product molecules contain ketone functional group? How many of these ketone molecule? Okay. Let me give you the shortcut and a simplest technique. Guys, as you can see, this molecule has a symmetry, right? And this part of the molecule is similar to that part of the molecule, right? So this molecule has symmetry. So from that perspective, I've told you one thing. When you have double bonded CH, it's going to be converted into CWH. And if you have just double bonded C with two alkyl group, obviously it's going to be converted into ketone functional group. So what I'm looking for, the double bonded C, so that I'll get the ketone thing. So this is double bonded C. 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 And obviously, it is a cyclic ring. So when concentrated, hot concentrated KMNO4 is used in this sort of scenario, this double bond breaks and cyclic rings open. All right. So this compound ruptures the double bond and opens the cyclic ring. This one, my bad. This one, this one, this one, and this one. So this molecule and this molecule would be the same. So we have 1, 2, and 3, 4, 5, and this one is 6. So in total, we have 6 products. Okay. What I'm saying that when this product is reacted with hot concentrated KMNO4, it's going to give you the structure like this. This is double bond. This is CH3. Okay. Oh, my bad. Okay. This must be the structure. This is going to be ketone, and this is going to be ketone with CH3. Okay. So that's the one molecule, right? Not two molecules. Over here, you will get the same molecule. So this is 1, this is 2, this is 3, this is 4, this is 5, and this one is 6. Okay, I hope it makes sense to you. That's the shortcut technique, guys. But in topical past papers, I have given you each and every fragment of this molecule, and from those fragments, I have given you the total number of ketone functional group in product molecules. Okay, so you have both shortcut and detailed analysis of this question with you. Question number 31. 1,1-dichloropropane reacts with aqueous sodium hydroxide in a series of steps to give propanol. Which term describes the first step of this reaction? Obviously, reactant is halogenoalkane, which means it is an alkyl halide. An alkyl halide is reacting with NaOH in the first step OH will substitute chloride. All right. So nucleophilic substitution reaction takes place in the first step because OH uh, are going to be replaced with the chloride ions. All right. So substitution is going to be the right answer. That is nucleophilic substitution or just substitution. Addition not possible because addition takes place in alkene. Elimination takes place uh, in alcohol, dehydration of alcohol. Oxidation is not possible here with NaOH because NaOH is an alkali, it is not an oxidizing agent. So since this compound is an alkyl halide and all alkyl halide undergo nucleophilic substitution reaction, so B would be the right answer. That's the shortcut technique. Question number 32. Propanoic acid, which is CH3, CH2CWH, and this propanoic acid has 3 carbon atoms. Can be made from bromoethane. Bromoethane is CH3, CH2Br, and this compound has 2 carbon atoms. Using a 2-stage process, which pair of reagent is most suitable? You know, the reactant is alkyl halide, and alkyl halide undergoes a step-up reaction in which we need to increase the number of carbon atom, and for that I will go with potassium cyanide or sodium cyanide in the first place, and then later on I will hydrolyze it in the presence of acid so that you will get carboxylic acid. So what I'm saying, we have discussed this in class, by the way. What I'm saying is, in the first step, alkyl halide undergoes a step-up reaction in which we need to increase the number of carbon atom, and for that I will use potassium cyanide because potassium cyanide is given in the question, in the option. As a result, I'll get cyanide ion in the product. This is the first step. In the second step, this cyanide undergoes acid hydrolysis. Acid hydrolysis is this, so that you will get propanoic acid. This step is called step-up reaction, also called nucleophilic substitution reaction. And a step-up reaction always takes place in alkyl halide. And step-up reaction is a reaction in which we need to increase the number of carbon atom by introducing the cyanide group into the compound. So now the main question is, why can't we use hydrogen cyanide? This will also produce cyanide ion because hydrogen cyanide is a weak acid, and this weak acid is only applicable in aldehyde and ketone, not in alkyl halide, which is why I'll go with D, and D is going to be the right answer. Okay. Option B and C. Option B is incorrect because it undergoes SN reaction, in which there will be no increase in the number of carbon atom. Option C is also incorrect because this is going to be the elimination reaction. Instead of propanoic acid, you will get ethene, which is not possible. Okay. Question number 33. Alcohol X gives a yellow precipitate with alkaline aquacidity. Whenever alcohol gives yellow precipitate, we have 2 types of alcohols, primary and secondary. So in primary alcohol, we have only ethanol that will give you positive test of hydroform. And since there is no such option is given, so we don't need to consider primary alcohol in this scenario. Now in the second scenario, we have secondary alcohol. Secondary alcohol undergoes positive test or gives positive test. When it gives positive test, when we have CH3, CH, OH group available in the molecule. One more thing, all of them are cyclic rings. Now this is secondary alcohol, but it has no CH3CHOH group, which means A is incorrect. This is primary alcohol, and primary alcohol uh, has ethanol, and ethanol gives positive test of iodoform, which means B is also incorrect because it cannot give iodoform test. C is basically tertiary alcohol. Tertiary alcohol cannot give iodoform test, and therefore D is going to be the right answer. Why? It's right because this is CH3, this is CH, this is OH. So basically this compound has CH3OH group. So because of this entire group, it will give you positive test of iodoform. It will give you yellow precipitates, and the yellow precipitates belongs to CHI3, and that CHI3 is called triiodomethane, also called iodoform. Okay, so D is going to be the right answer. When ethanol reacts with sodium metal, obviously sodium ethoxide and hydrogen gas is produced. We have discussed this reaction in alcohol. This is sodium ethoxide and hydrogen gas is produced. Obviously, we need to balance the equation like this. Okay. Ethoxide ions means these ions are produced. Okay. When water reacts with sodium metal, okay, when water reacts with sodium metal, obviously highly exothermic reaction takes place and you will get sodium hydroxide and hydrogen gas. So from ethanol, you are getting ethoxide ion, whereas from water you are getting hydroxide ions. Okay. Which statement about these reactions and ethoxide ions are correct? Correct statement we are looking for. Okay. At the same temperature, the rate of reaction between sodium and ethanol is greater. Absolutely incorrect. Because when sodium reacts with water, reaction is extremely vigorous and explode, and reactions sometimes explode because of the high reactivity of sodium. So ethanol is less reactive. It has lower rate of reaction with sodium. Obviously, A is incorrect. Let's talk about B. Ethoxide ion is a stronger base than hydroxide due to electron donating effect on the ethyl group. That might be the right answer. Let me explain it to you. This is a stronger base, okay? And a stronger base means can accept proton easily. Can accept proton easily. Why it is accepting proton easily? Because it has an electron donating group. It has an electron donating effect, and because of that, lone pair on the oxygen atom is easily available for protonation, right? Let me explain it to you. Let me explain it. This is CH3. This is CH2. This is O negative. Now this oxygen has a lone pair also. Now this CH3, CH2 electron donating alkyl group. This electron donating alkyl group has a positive inductive effect, which means this group will donate electrons towards oxygen. Donate electrons or provide electrons to the oxygen atom. As a result, electronic density on oxygen atom increases. If electron density on oxygen atom increases, then it means this lone pair is easily available for protonation. Lone pair can accept proton easily. So it is a stronger base. than hydroxide ion, which is why B is going to be the right answer. Next, statement C is negative charge on the oxygen in ethoxide ion is delocalized. Well, this oxygen has a negative charge and it cannot delocalize because of the absence of this carbonyl group. All right. So cannot delocalized. Next is it is easier to deprotonate ethanol as it is more acidic than water. By the way, ethanol is weaker acid than water, not more acidic. Also, you can say that ethanol is neutral, so it is not more acidic. Okay, I hope it makes sense to you. Because when you have an alkyl group, which is an electron donating group, it donates electron towards oxygen atom like this, which is why, because of this, the electronic density on the oxygen atom increases. If electronic density on the oxygen atom increases, this lone pair is easily available for the reaction, which means this lone pair can easily accept proton, and therefore it's going to be the stronger base. Okay. 35. Menthol is naturally occurring alcohol. Okay. When menthol is heated with concentrated sulfuric acid, it reacts. Obviously, if you are reacting an alcohol with concentrated sulfuric acid, meaning meaning dehydration takes place. And when we have a dehydration process, obviously, alkene would be the product. So what we are looking for is the alkene. All right. So option B is incorrect because it is not an alkene. Okay. So competition exists between A, C, and D because these three options have alkene functional group. So now we have two different situations. According to my lecture, this carbon has hydrogen. Similarly, this carbon has hydrogen. So either you can remove this hydrogen or you can remove that hydrogen. Okay. So as a result, you will get two different sort of products. So I'll remove when this hydrogen and this OH, obviously pi bond is going to form between these two carbon atom like this. If I remove this hydrogen and this OH, obviously pi bond is going to form here in the cyclic ring. All right. In both the products, double bond is present in the ring, not outside the ring. All right. Which means option A is also incorrect. Now competition exists between C and D. Obviously double bond either present here in the cyclic ring or there in the cyclic ring, but cannot form here on the cyclic ring, right? Which is why C is also incorrect, and therefore D is going to be the right answer. Why I have made the pi bond here? Examiner shows the structure here. So I have made pi bond over here in the cyclic ring. Examiner shows the pi bond here in the cyclic ring. Why? Because this molecule has symmetry. This molecule has symmetry. So if you rotate this, you will get the same structure. Okay, so it doesn't make any difference. Question number 36. Which compound will produce a yellow-orange precipitate when added to 2,4-DN-PH? 2,4-DN-PH is always applicable for aldehyde and ketone only. This is not aldehyde. This is ester, not aldehyde. This is carboxylic acid, not aldehyde or ketone. This is ketone. It is right, and therefore D is going to be the right answer. Okay, that's an easy question. Question number 37. ethanol, which is an aldehyde, undergoes an addition reaction with HCN in the presence of cyanidine, and so that cyanohydrin is formed, which identifies the type of reaction. All aldehydes, all ketones undergoes nucleophilic addition reaction. So type of reaction is nucleophilic addition. That means A and B options are incorrect. Now let me write the whole structure which I've given you in the class. This is CH3. This is COH. If you're reacting it with HCN in the presence of cyanidine, so first of all, this cyanide reacts with the carbonyl carbon. At the same time, pi bond shifts on the oxygen atom. You will get an intermediate with the charge of minus on the oxygen atom. So we are getting an intermediate in which oxygen has a negative charge. So this is CH, this is CN. Okay, this is my first step, guys. In the second step, this negatively charged oxygen atom reacts with HCN, which is a weak acid. So it has slight positive, it has slight negative. Obviously, this negative charge of the oxygen atom reacts with this hydrogen atom so that an OH bond is formed in the product, like this, and this CN will remain as it is, whereas this cyanidine removes in the form of cyanidine. So CN is removed in the form of cyanidine. So reaction starts from cyanidine, and we are getting the cyanidine at the end of the reaction, which means cyanide is acting as a catalyst. What is the name of this compound? Basically, this is the longest carbon chain. So we have 3 carbon atoms in the longest chain, which is why it is called propane nitrile. So propane nitrile is here. This is ethane nitrile, which is not possible, and therefore C is going to be the right answer. Let me give you one more hint. This is the first carbon atom, this is the second carbon atom, this is the third carbon atom. So we have OH group on the second carbon atom. So if we have OH group on the second carbon atom, so compound ka naam would be 2-hydroxy propane nitrile. So 2-hydroxy propane nitrile is given here, and therefore C is going to be the correct answer. Next is I think that's an ester. Okay. So the structure of compound X is shown. What is produced when X is heated? So that's basically alkaline hydrolysis of an ester. When we talk about alkaline hydrolysis, obviously we are getting 2 products. The first one is alcohol, and the second one is salt of acid, because it is an alkaline hydrolysis. Let me apply the basic concept first. Carbon oxygen single bond needs to be broken. Oxygen will get hydrogen of water, whereas CO is getting OH of water. Okay. So this oxygen is getting hydrogen of water, and CO is getting OH of water. As a result, I'll get the product, and the product would be like this. This is C, OH, then we have CH2, then again we have CH2, then again we have CO, O and A, because it is a salt of acid. See, this is CH3 here, this is CH here, this becomes OH after getting the hydrogen from water. This one, this is CH2, this is CH2, this is CH2, this is CH2. After getting OH of water, it will turn to CWH, and because of this alkali, it will turn to a salt. So This is incorrect because it is not salt. Also incorrect because it is not salt. No competition exists between these two options. This one and this one is correct. Then we have CH2, we have CH2, we have CH2, we have CH2, we have CH, we have CH, we have OH, we have OH, we have CH3, we have CH3. So from my perspective, what we are looking for, option C. Why not A? This is ONA, ONA, this is CO, this is CO, this is CH2, this is CH2, this is CH, CH3. So they are, this CH2 is missing from this. Okay. Because CH3, CHOH exist altogether, whereas in this it is different. It is CH2OH, whereas this is CHOH. That's a different thing. Okay, so option A is wrong. I mean to say that this is CH2OH group, whereas this is CHOH group. So this is secondary alcohol, this is primary alcohol, and both the groups are different, right? That's not possible. Groups can't be different after hydrolysis of ester. Okay, question number 39. Okay, the infrared spectrum of compound L is shown. So from 500 to 1500, we have a fingerprint region, and there is no peak as such here. From 1500 till this, no peak present, no carbonyl. So CO group absent. Now we have this peak approximately at 2900 degrees Celsius or 2900 centimeter inverse. That indicates the presence of CH. And we have another peak here at 3350 centimeter inverse, which is close to 3350 centimeter inverse. This is 31, 32, 33. Sorry, 31, 32, 33, 3350. Okay. So that must be an alcohol, which is OH. All right. So 3350. So this is your 3350. That is hydroxy. That means OH functional group, right? So we have alcohol functional group. Option A is incorrect because carbonyl peak absent in the spectrum. Similarly, it is aldehyde. Aldehyde contain carbonyl. So carbonyl peak absent. Then we have carboxylic acid. Carboxylic acid, very broad peak absent. Very broad peak of carboxylic acid can be drawn like this. Right? This is a very broad peak. So this shape is not given in the spectrum, which means D is also incorrect. And therefore C is going to be the right answer, because in C we have only alcohol functional group. All right. And that's the spectrum is talking about, that we have an alcohol functional group. Last question of this paper. In the mass spectrum of compound J, the ratio of the heights of M+1 peak and the height of molecular line peak is 4:91. Okay, compound J forms a carboxylic acid when heated with acidified K2Cr27. Oxidation takes place. So butanol won't be the right answer because butanol cannot oxidize. Similarly, propane nitrile cannot react with potassium dichromate 6. Okay. So let me calculate the number of carbon atom by using these equations, right? Number of carbon atom equals to 100 over 1.1. Abundance of M+1 peak, which is 4. Abundance of molecular line peak, which is 91. So N is basically 3.99, and that gives me 4. So obviously this option is incorrect because this option has 3 carbon atom, right? CH3, CH2, CN. So we have 3 carbon here, which means it is incorrect. And also cyanide cannot oxidize with K2Cr2O7. I didn't discuss any sort of reaction with you in the organic chemistry, right? Which means that's not possible. Propane 1-ol is also incorrect because propane 1-ol has 3 carbon atoms, whereas we have got 4 carbon atoms. And also when propanol is treated with K2Cr2O7 under heat, obviously it's going to be converted into carboxylic acid. Okay, but that's the 3 carbon atom acid, whereas we have 4 carbon atom. So right answer is going to be, so I think option A we are looking for, because we have butanol in which we have 4 carbon atoms. So this compound satisfies the number of carbon atoms, and aldehyde can easily oxidize in the presence of K2Cr2O7 under heat, is going to be converted into carboxylic acid. Okay,